Hi everyone, in this lesson we will be graphing functions by making t-charts, or by making tables. Okay, so first problem, we're going to make a table here, and to make a table we'll use points -2 to 2, so -2, -1, 0, 1, and 2, and just plugging these numbers in. So if you plug -2 in for x, we have -2 times -2 is +4. 4 plus 1 is 5. Plug -1 in, and you'll get -1 times -2 is +2, plus 1 is 3. Plugging 0 in, you'll get -2 times 0 is 0, plus 1 is 1. We see a pattern 5, 3, 1, so we're always taking away 2, so 1 minus 2 is -1, -1 minus 2 is -3. Now we're going to plot these points on our graph. Here's the x-axis and the y-axis. So plotting the points, we're at -2, 5, right here, -2, 5. We're at -1, 3. We're at 0, 1. We're at 1, -1. And we're at 2, -3. We see that all of these points make this straight line, so that means that the graph is linear. Not all of our graphs in the lesson will be linear, but this one is. Plugging in values, so if we plug -2 in for x, then it's 3 minus -2, so minus negative. 3 minus -2 is actually positive, so that's 5. If you plug -1 in, it's 3 minus -1, so that's 4. Plug 0 in, and it'll be 3 minus 0 is 3. We see the pattern 5, 4, 3, 2, 1. If we plot these points, we're at -2, 5. We're at -1, 4, 0, 3, 1, 2, and 2, 1. So we see that this graph is also linear. So we'll put arrows on both sides to say that it goes on forever. And this one, okay, so making a t-chart. Always making our t-charts from -2 to 2 in today's lesson. Okay, so if you plug -2 in, we're going to have absolute value of -2 plus 2. So absolute value of -2 makes it positive, so it's 2 plus 2 is 4. If you plug the next one in, absolute value of -1 plus 2, we'll get 1 plus 2, so that is 3. Plug 0 in, 0 plus 2 is 2. Plug 1 in, 1 plus 2 is 3. And plug 2 in, and 2 plus 2 is 4. So plotting these points, we're at -2, 4. We're at -1, 3, 0, 2, 1, 3, and 2, 4. So what we see happening here is that we get this V-shaped graph where we're taking negative values, or normally negative values here, and reflecting them upwards to create this V-shaped graph. So this graph is our answer. In this problem, making a t-chart, okay, so we have -2 to the third. That means -2 times -2 times -2. So -2 to the third minus 4. -2 times -2 is +4 times another -2 is -8 minus 4 is -12. The next calculation, plugging -1 in, -1 to the third minus 4. So doing that on a calculator and using parentheses, we'll get -1 minus 4 is -5. Plugging 0 in, 0 times 0 times 0 is 0. So 0 minus 4 is negative 4. Plugging 1 in, 1 times 1 times 1 is 1. 1 minus 4 is negative 3. And plugging 2 in, 2 to the third minus 4. So 2 to the third is 8. 8 minus 4 is 4. So we have our table. Next step is to plot the points. So we're at negative 2, 12. Negative 2, negative 12. Here's negative 2, 12. Negative 2, negative 12. Left 2 down 12. Now we're at negative 1, negative 5, negative 1, negative 5. Then we're at 0, negative 4. Then we're at 1, negative 3. And we're at 2, 4 right here. So we see that we have this graph that follows this curve like right here, approximately. And what we clearly see is that this one is non-linear, meaning that it's not a straight line. In this one, to plug negative 2 in, we have to plug in with parentheses. So it'll be negative parentheses negative 2 squared. So ignoring this negative here, then negative 2 times negative 2 is 4. So you have 4, but then you're bringing down this negative, and you have negative 4. Okay? Negative 1, plugging that in, you have negative parenthesis negative 1 squared. So ignoring the negative, negative 1 times negative 1 is positive 1, but then attaching the negative, we have negative 1. Plug 0 in, and we get 0. Plug 1 in, 1 times 1 is 1. Then make it negative. And plugging 2 in, 2 times 2 is 4, so negative 4. Next, we're going to plot those points. So plotting negative 2, negative 4, so left 2, down 4. Then we're at left 1, down 1, negative 1, negative 1. 0, 0. We're at 1, negative 1. And we're at 2, negative 4. So we get this shape here, which is this curved shape. It's not a straight line. Like that. This graph is also nonlinear. A couple definitions. A continuous graph is a graph that is a straight line with arrows on both sides, meaning that the graph goes on forever, compared with a discrete graph having discrete items. Okay, so that would be just simply points on a graph where we are not connecting the points. So for continuous graphs, decimals are possible, because connecting it, we have all these decimals in between points. But for discrete graphs, decimals are not possible, meaning that we have to have integral numbers, and we just have points. We do not connect the dots. So looking at a couple of examples. Okay, so this particular one, the amount of water W in a waiting pool in gallons depends on the amount of time. Okay, so we can create a T-chart for this, where here's T like our X, and here's our W that we're calculating. Okay, so I'm just going to, since it's a real life, I won't plug in negative, so plugging in 0, 1, 2, 3. So that's for minutes. Plugging in 0, we'll have 0. We're plugging into this equation. Plug 1 in, 3 times 1. 3 times 2 is 6, and 3 times 3 is 9. So if I graph this, okay, so here's my t-axis and here's my w-axis for y, and I'm at 0, 0, I'm at 1, 3, I'm at 2, 6, and I'm at 3, 9. And what I can clearly see is that this is a continuous graph, because it's possible for me to have parts of minutes. I could have like 2 minutes and 45 seconds and see how much water is in there. But comparing this one, that's continuous, and it's possible for me to have decimals of how much water is in the pool, compared with this one. The cost C for baseball tickets depends on the number N of tickets bought, according to C equals 16N. So if I make a table here, I could have bought 0 tickets, I could have bought 1 ticket, 2 tickets, or 3 tickets. So plugging this in, 0 tickets, so plugging 0 into the equation, I'll have 0. Plug 1 in and get 16. 2 times 16 is 32. 3 times 16 is 48. Okay, so making a graph. So I just made a couple decisions, okay? So here on my x-axis, that's tickets. That's tickets. And then on my y-axis, I have cost. And the cost just in intervals of 10, so 10, 20, 30, 40, 50, up to $50, and up to 3 tickets. Okay, so plotting these points, I'm at 0, 0. I'm at 116, so 16 is about a little more than halfway. I'm at 232, so just a little bit past the 30 mark. And I'm at 348, so just under the 50 mark. So right about here. But the point is, in this graph, is it's impossible for me to buy a part of a ticket. So as a result, I'm not going to connect the dots. This is a discrete graph because I cannot have a fraction of a ticket. And there you have it. See you in class.